Hello everyone and welcome to today's webinar, Warranty Management Transformed Through Artificial Intelligence. My name is Simran and I will be your moderator today. I work in the marketing team here in Tavant and I'm very excited to be hosting this session. Before I hand the mic to the speakers, I have a few housekeeping items to cover about this presentation and the platform. First, the presentation and the recording of this webinar will be available online. Second, if you have a question for our speakers, please feel free to type your question in the chat window on the right side of your screen. Without any further ado, I'd like to kick off things by introducing our first speaker for the day, Ali Pinder. As the program director, Ali leads IDC's research and analysis of the service and customer support market for the manufacturers. This includes topics such as field service, warranty operations, service parts management, and how these service areas impact the overall customer experience. He is also responsible for research which aids manufacturers as they evaluate innovative technologies like 3D printing, augmented and virtual reality, and the use of IoT and advanced analytics for remotely monitoring and managing assets. Our second speaker for today is Atul Vajnia. Atul heads Tavant's artificial intelligence and machine learning business. He is an accomplished technology executive with extensive knowledge of AI/ML and software technologies. Atul has held leadership positions in companies like Samsung, Agnity, Bay Packets, and Motorola. He has a PhD in parallel computing and is passionate about AI/ML and quantum computing. Today, we will explore the trends driving the manufacturing and service industry, the transformation happening in warranty management, and the impact of AI on the future. All right, over here, I will hand it over to Ali. All yours.
Thank you, Simran, and thank you all for joining today. Once again, my name is Ali Pinder, and I'm the research director here at IDC, running our service innovation and connected products team. Before we dive in, it is important for me to lay out the IDC manufacturing team's definition of warranty management. The data you'll see today frame warranty management as the stages of the warranty process, including registration, claim capture, claims validation, early failure detection, fraud detection, recalls, parts return, adjudication, extended warranty, supplier recovery, and reserve optimization. You know, there's a lot there, and probably some aspects that I even missed on this slide because, you know, we can only get so many words on a slide like this. But, you know, as you consider warranty management, our perspective is that it's the end-to-end process and not just one or two aspects. So let's take a look now at some of the key trends which are impacting your business and leading you to join a webinar like this today to learn more about warranty management and how technologies like artificial intelligence are steering your decisions and decisions broadly around investments in capabilities, processes, and people. So first up, you know, warranty is, you know, an aspect of the service lifecycle management set of capabilities, and I would argue an integral aspect of service lifecycle management. It is important to understand what trends are driving manufacturers and service organizations as they consider investments in technologies and rationalize what innovations are needed today. Each year, IDC comes together with a series of predictions that we base off of a number of macro trends that we research throughout our annual research agendas, and a few of those I'll lay out today. First off, you know, customer expectations are rising, and this isn't anything new, but it is becoming ever more critical to manufacturers and businesses as you think about ways in which your customers are pushing back on the services and offerings that you provide to them. You know, we now compete not just on new products that are being purchased, but also as more and more offerings become subscription-based, it's important to understand, you know, what are the products, you know, that your customers demand, what are their buying behaviors, and how can you get better and better information to not just look at this as a one-size-fits-all, as that's an out-of-date set of offerings for customers. You know, next up is set, compute, and actuate. You know, this is, you know, fairly rudimentary, but, you know, when I think about ways in which technologies are impacting our businesses today, it's not just about capturing more and more data, whether that be from the warranty side of the business, from products, or from other systems, but it's actually what you're doing with that data. How can we turn data into value for customers and value for your organizations when you think about your dealers, your supplier network, and your internal operational teams? The next driver is platform disruption, which looks at how aspects like cloud and analytics tools help organizations scale. No longer do we expect to innovate in a silo or within just one region with no impact to suppliers, partners, distributors, dealers. A platform approach enables the level of coordination needed to connect all applications and systems necessary to innovate with agility, speed, and accuracy to solve new problems. Next up is the pace of change as we look at how organizations can adapt to speed at which change is happening within a digital world and business. The ability to move quickly and evolve your business at the speed at which customers demand and at the speed at which technology around you is all evolving. It's important that we move beyond just thinking about the world as the status quo environment, but actually looking at the way in which we can innovate, not only at the speed that our internal IT teams or our leaders want to change, but at the speed at which we need to change to beat back competitors and meet customer expectations. Next up is the ability to empower the material world, which explores the applications of digital technologies to extend our systems and processes to be able to support a broader reach when we think about the growth of our business. Next to last is the fact that we all are dealing with this long tail of legacy infrastructure and somewhat of inertia that we're looking at when we think about our technological view and infrastructure within our business. It's really difficult to advocate for any buyer, IT buyer, or service leader to think about ripping and replacing all the technology that you have in place, whether they be ERP systems or CRM or even some homegrown solutions. It's important to, as we think about innovation, to think about how innovation can interact with our current technology while we also look at supplementing the new capabilities we need to explore and evolve within the ecosystem. And then finally, it's important to think about how autonomy and artificial intelligence is really working to help change the way in which we view our world around us and those services that we can provide to the market. AI is no longer a sci-fi concept. It's important that organizations understand how they could build out AI tools to support their ability to evolve and innovate, but also how they can capitalize on the wealth of insights that we're gathering on a day-to-day basis. So, however, with the promise that there is within, all of those drivers of business, it's important that we, address, plan for, and at least are aware of, the number of ways in which our world around us is interacting and engaging. It's important that we look at an opportunity to figure out, what around us is impacting our business. And I wanted to share this slide because, in a lot of ways, we think about service and our ability to interact with our world around us as just a way to do things better. But more and more of your peers and organizations are thinking about, how does connectivity impact our business today? And top of mind for many organizations when they think about disruption is the impact that security concerns have on the way in which they're going to invest in tools and technologies. It's no longer just about, beating back competition or, cutting costs when we think about the ability to leverage technology to support our business. But as we become more connected, it's important to address and understand, what does security mean for our businesses? How can data flow between the OEM to the dealer to suppliers to customers in a secure manner? And how can we make sure that we're able to address all those concerns as we continue to innovate? And, as we continue to transform our business models, it's important to understand how organizations are transforming from reactive to proactive, predictive, and prescriptive models of service and action. And this is truly a way that manufacturers can deliver increased value to customers and show a direct ROI from technology investments. For some time now, actually since service began, it depended on someone notifying the manufacturer or service organization of the issue, whether it be from a phone call, an email, a physical return, or a social media post. Service wasn't something that happened until the customer first did something. A real-time data from field assets and products and automated warranty management solution provides the service organization with the ability to finally get to this point of exceptional service where we're no longer reactive and we're much more so proactive and predictive, and all of which is things in which we talk about at conferences and webinars. But the challenge, is how can we take all that, that data and actually move to a point where we're able to notify the service organization or customers of a pending failure and actually act on that information. As you can see, despite all of the advancements we're making, we still have some way to go to become 100% prescriptive. And we probably won't ever get all the way to 100%, but there will always be a time when, even if you have the ability to be prescriptive, it may not be the most efficient or cost-effective delivery model of service. And also, we may always have some equipment or products which aren't connected in the install base, which, require a reactive level of support. But even in those cases, having real-time information available and accessible to better understand the reason for failure or detect the parts or skills needed to fix the problem in the appropriate time to tackle the issue will be critical to success. Break fix isn't always a bad thing, but organizations should ensure that they have the visibility as to when it is the right time for this model and how to be best equipped to be efficient and solve the problem the first time on that reactive service visit. As organizations migrate from reactive service models to more proactive and predictive models, there are some additional key drivers that you should address or be aware of. Top of mind of this next set of drivers for a business is the ability to capture service knowledge across the service business, but also to make it accessible to the right stakeholders within service and across the network. Organizations are also looking to drive new revenue streams from service, and this is beyond the historical channels of more labor, charging for overtime or parts when we think about consumables, to find new paths to revenue such as the warranty side of the business, training or reporting tools. And another top driver should come as no shock as we continue to live in an experience economy is the need to deliver value to customers and be faster to respond to product quality issues and customer complaints. All three of these are areas are top drivers that are relevant to warranty management. And if you're not seeing these drivers impact your business, you will in the near future. But those are not the only drivers that show the opportunity and role that efficient warranty management tools and capabilities can play for organizations. Organizations are also looking for improved collaboration across teams within business, such as service, marketing, sales, and engineering. These teams often work in silos, but organizations are beginning to understand this should not persist. The data is too valuable to stay within disparate systems and not be accessible to others. Also, more and more organizations see an opportunity in taking data from actual performance of assets, equipment, or products and using that data to improve current products, future products, and the services being provided. Again, as organizations see the need to improve the customer experience, taking real-time data and leveraging that insight to deliver value will continue to be more critical for business. But I also wanted to call out that the desire to reduce costs, continues, just struggles to be, a top 8, trend or driver as service leaders think about their businesses. Now, this isn't to say that it isn't or shouldn't be a concern or an area to be addressed, but it is important to think about your business and service specifically a bit differently when we think about the way in which we viewed it in the past. If I think back 5, 10, 15 years ago, containment or reduction of service costs would have been either 1 or 2 on this list. Innovation, customer value, improving the service experience all outpace a manufacturer's desire to just cut costs out of the business. And as you think about your warranty processes and the tools you leverage, cost should be a part in a determining factor, but it can't be the top reason why you look at these tools. Now, the drivers and the macro pressures facing organizations set the table for what is impacting decisions regarding investments in tools for warranty management and the broader service applications and technology. As we continue to explore warranty management, it's important to think about a few questions. These are areas that a number of you are facing today, or that you should at least think about addressing as you move forward. First off is, what does connected service mean for warranty management? Can we take IoT and AI and the ability to connect to products and equipment and actually help that drive our abilities to evolve and impact our ability to deliver better warranty services? Who owns the warranty journey? Is warranty management something that's owned by operations or service, by marketing, by sales? Who actually owns the processes that are involved in delivering warranty to our businesses? How do we get our dealers up to speed quickly? Are they on AS400 systems? Can we get them to the point where they have technology and tools to support their ability to provide efficient and accurate data when we think about processing warranty claims. How does best-of-breed applications fit into our infrastructure? Should we think about moving beyond those homegrown or legacy systems to really leverage tools and systems and processes that are specific to our industries, specific to warranty management, and can provide us with that breadth of information and that ability to scale? And finally, how can we keep up with changing customer expectations? Again, if I think back, just even 5 years ago, the customer wasn't really impacting our mindset as we think about investments around warranty management. It's important to think about ways in which we can really make that next step and get to the point where we're thinking about our customer in every decision we make. And as we look at that evolution, it's important to think about what are the key drivers specifically for warranty in 2019. Again, the customer experience should be paramount to your initiatives, your investments, and the way in which you're thinking about the warranty side of the business. Is warranty management key to helping you drive at that customer experience and value? Is warranty an opportunity for you to drive new revenue streams and generate those revenues? Again, in 2019, it's still going to be a challenge as we think about containing costs, but it's important to not think of reducing costs as being the main driver. It's important about delivering value and transforming your organizations through the warranty side of your business. But the value being driven from technology and specifically around innovations like the IoT and warranty management go beyond just service operations. In the next year to 2 years, your peers are beginning to tap into how IoT and other technologies can enable better product innovation, help expand into new markets, tighten relationships with customers, improve revenue opportunities, and ensure products are manufactured with improved quality. The ability to take real-time data across the organization, even down to the warranty processes, and make use of that data beyond just getting better at service execution is a huge opportunity for businesses and for you and everyone on this call. The more you can incorporate a value discussion which goes beyond service, the better suited you'll be to go back to IT and your management teams and request investment dollars and resources for service. A number of you on this call are looking at how cloud is going to impact your investments, specifically around the ability to support warranty management. This isn't only deployment model or strategy, but I think what is important from this slide is the trend that shows how manufacturers and service organizations across industry verticals are beginning to see the value and the opportunity of being agile and being able to scale the technology that can support warranty processes. More than half of the respondents today are in the cloud relative to warranty management and warranty technologies. Updates that can be faster and partnerships that can be made from an organizational perspective, recognize the role that warranty must play along a digital journey. It's no longer just an afterthought for many of your peers or a one-time investment, but part of a strategic investment for success. And it's important to think about warranties that way. So those are a few of the trends impacting your organization and warranty management as you think about the age of experience and the ability to think about ways in which your organization should think about technologies tied to warranty as you become more customer centric. But now let's look at the future. Going beyond the hype to explore how innovative technologies can play an integral role in warranty management in the near future and not just far off in sci-fi films. So just a few slides ago, I noted how organizations are looking to the IoT to deliver value and how that value can go beyond service. But what is critical to understand is how connected products are enabling organizations to think creatively and solve problems that they didn't even know existed or that they didn't even think they could solve. I talked recently to a couple auto OEMs who have used the data gleaned from connected vehicles and linked it to warranty data to create new educational and marketing collateral for their dealers and customers to improve their use of products, improving both the customer satisfaction and the dealer engagement levels within their businesses. I recently also spoke with a few industrial manufacturers who have worked with their dealers to share data on their peers and their peer dealers to create a best practice repository and set of tools to help their ability to service equipment that comes in for repair or even proactively engage the end customer to avoid a bad experience or future failure. But to do this, organizations must think about how technologies can support this bigger set of ideas. And there's a lot of technologies out there. This is a pretty analyst slide, and there's a lot of data points here. And I won't go through each of these technologies or capabilities, but I wanted to show that today and in the next year, organizations are not just evaluating technologies such as the IoT or augmented reality or blockchain or AI or social, but they are recognizing the importance of these innovative technologies to their success for the future. These technologies are no longer just a cool thing that is being hyped, but pilots are turning into investments and deployments. And it is imperative that you think about where these technologies can fit within your business, even within warranty management. That being said, it's important to dive even deeper into a few of these technologies, first of which being artificial intelligence and machine learning. The number of organizations stating AI will be very important or rank as a 5 more than doubles with regard to the level of importance for the coming 12 months. The use cases are growing exponentially, and if you don't have an AI program or a perspective in place today, you need to establish one. The volumes of data being gathered demand that you invest in resources or tools to be able to analyze the data and turn it into actions, that can be acted upon, preferably without too much human intervention, because the data is coming in too fast. One manufacturer I spoke with recently talked about how they were leveraging AI to call through volumes of warranty claims to identify trends regarding customer behavior, identify risks of potential defects leading to a recall, and better understand what fields should be pre-populated, streamlining the claims process for dealers and customers alike. There's really a big use case and opportunity for us to think about ways in which AI and machine learning can tap into a wealth of data to help support our ability to not just process more claims, but actually deliver more value to customers when we think about warranty management. But in order, for AI to really take hold, you need the data to actually do something, right? And for this reason, more and more organizations are investing in the IoT to connect to assets, products, equipment in the field, but also to provide more detailed insights. IDC projects that the IoT market will continue to grow, and it will be less about the number of connected devices, which is something to keep in mind, but that the dollars that will be invested to drive at investments and insights from these connected devices. More than $1 trillion, in 2023 tied to investments around IoT. It is important, obviously, to get vibration data from the pump, but it's also critical to get the location data from remote equipment to see if it is being used in the deep, used from in a mine, deep on a remote site, when it should only be used above ground, or, are we able to capture data to understand, for what climate are these assets being used, leading to more fast erosion from an engine perspective earlier than you previously determined from an OEM perspective, and reach out to dealers based off of that, IoT connected data to maybe notify the dealer or the customer that, proactively that they can improve productivity of the asset if they just use it in the right environments that we discussed. Can we connect into those remote assets and proactively provide a view into why a warranty claim will not be processed or why a warranty will not be approved because the asset's being used out of the parameters of the SLA. Can we tap into IoT data and really provide that use case for warranty claims process that can be improved? And, without, it's impossible for me to be an analyst and not comment on the number of devices to be connected, but it's important to, again, think about the fact that, we're continuing to see this trend move forward around investments tied to the level of connectivity from an asset perspective, and more and more products will be connected in the near future. And it's not about, when we'll get there, but it's about how we'll leverage that data around the IoT to support a number of use cases within our warranty business and our service business. And these investments, in the IoT will be the bedrock around innovations tied to a number of use cases across the service landscape and service ecosystem, not least of which being the warranty side. But I want to, highlight a few of the top use cases I'm seeing today from an IoT perspective. And, top of mind is the ability to tap into remote services and provide those services to customer, the ability to augment service, whether it be from an AR or VR perspective, and collaborate between a centralized expert and an end consumer and customer, a dealer, or a field team, when you think about ways in which you can interact and engage and collaborate. The ability to tap into IoT data to self-diagnose issues on equipment. So can we leverage this data being captured in the field to actually diagnose issues in advance of failure and provide a response that's more accurate based off of the way in which we need to interact with customers. The connected and autonomous vehicle. I don't think we're going to get any to full level 5 autonomous anytime in the near future, despite our best efforts from some leading technology and digital companies. But we are getting to a point where connected vehicle data is enabling our ability to think about ways in which we can process warranty claims, figure out ways in which we can connect to asset data prior to an owner bringing that vehicle in for service to help us resource appropriately. And then finally, connected warranty management. This is something that I continue to see an opportunity in. The ability to take IoT connected products and efficiently process warranty claims, improve the services being delivered, more accurately provide a better experience to customers based off of capturing that data, connecting the warranty side of the business to the remote IoT data. Each year, IDC comes out with a number of predictions, and here's one that I published specific to warranty management, and I want to share that with you all today. By 2023, I predicted that 40% of manufacturers will leverage IoT connected products and artificial intelligence tools to validate warranty claims, preventing, errors by 80%. This may be a bold statement, but I think it, highlights the opportunity around the IoT. Why can't we, leverage connected product data through a level of intelligence and use that to prevent fraud and errors? But in order to do that, you need to make sure that you have the IT team in place and involved in this level of interaction and engagement. It's important that IT, make this data accessible to the service team in real time. That IT, has to invest in robust analytics tools, which understands the variety of data that is needed and is logged within warranty processes. It's not every IT team that understands the nuance that's involved in warranty claims. And that the IT team creates data flow, from the customer to the dealer, all the way to suppliers and the OEM. And the front line also needs to be involved, right? It's important that we understand, how we can leverage these tools, around root cause analysis, provide end customers with a pathway to get access to this information, and leverage AI capabilities to improve the service experience and product quality. I would argue the promise is there. We just need to continue down our digital transformative journeys. And I think we can get there. 2023 isn't too far off, but I do think, and I do see more and more manufacturers connecting the dots between IoT, AI, and the ability to process claims more efficiently. And as noted, it's important to understand that IoT isn't being viewed across a number of industries as just being a consideration or a pilot or a trial. A number of organizations think about IoT as a strategic lever for their businesses, allowing them to effectively improve product services today while also cutting costs. I think the number of organizations will grow on the transformational side of the business. Today, it's still more of a strategic investment for businesses as we look at moving forward. This is another interesting slide. When I see the value around IoT, it's important to understand that it's not something that should be driven by IT alone. It's not something that should be thought of as only a business decision. It is something that needs to be leveraged by both business and IT working together to invest in the right ways to support initiatives that go beyond the hype, right? I think one of the reasons why many organizations struggle around IoT investments early on or other innovative technologies has been that it's been either driven by one or the other, not having both teams talk to each other. It's important that, IT has, their selection criteria being addressed around security and risk and compliance, But it's also important that the business understands and has a view into the tools that are being leveraged so they can be industry specific around automotive or high tech, which has different needs, or that they can support the actual ability to deliver on the service promise. So, without talking too much about future innovation, it's important for us to, have a perspective on other technologies that I see in the market, and I think will be top of mind for service leaders, specifically around warranty in the future. And I want to highlight one area where I don't think we're seeing enough conversation today around the interaction around warranty management and the way in which we can look at how service is impacted by technology. And that's blockchain. I think many of us still view blockchain as being a cryptocurrency or, a way to speculate on the financial market. But we're seeing more and more organizations at least test and try pilots around, smart contracts and connected product analytics tied to blockchain specific around service. And I don't, see this as being something that, next, 2 years, it'll be really prevalent. But, definitely when you think about the next 5 to 8 years, you'll see more use cases around blockchain, specifically around warranty and around service operations. A much bigger use case is around AI and artificial intelligence. And, again, I think too often we think about AI as being a way in which organizations can get at automating, their repetitive tasks. And what I want to highlight in this slide is that isn't the case. Many of your peers today are leveraging AI tools to plan for service, execute on service, and, optimize the experiences that customers are receiving from the service side of the business. AI isn't about, data scientists or machines. It should be about ways in which we're leveraging artificial intelligence to support our businesses. And that includes warranty management and the ability to process claims more efficiently, drive more intelligence and investments and insights out of the data coming back, and really looking at ways in which we're able to transform organizations to support customers in the future. And all this is enabling organizations to take that next leap from being a business with digital tools to being a digital business. Customers and employees expect, as we continue to have, virtual assistants in our home, continue to be able to leverage applications to get from point A to point B, we expect that the businesses we interact with won't just have technology and applications, but they'll truly become digital businesses that support our needs as we continue to move forward. And along that journey and that level of maturity, AI and machine learning isn't something that is not going to be at the forefront of ways in which we're able to get to that level of digital. 2/3 of organizations within our sample, see a pathway around how AI is going to help them transform their organizations. The potential is not just there; it's being seen within organizations, and 1/3 of organizations are already there with the pilot or operational or leveraging of AI. But 2/3 of organizations understand they need to have a perspective around what AI will mean for their business. And I think this is an opportunity for warranty to really play a big role in helping organizations make that business case around AI. And one level below that is within service. When we sampled how organizations really see tactically and operationally how AI is going to play a role in their business. And again, it goes back to the planning piece. It goes back to leveraging artificial intelligence to improve the ability to service equipment and assets and move from proactive and reactive to preventative, but also on design improvements. And I think this is really a way in which warranty management can play a role in connecting those dots around AI. And it's an ability to ensure that we're getting that defect in claims data and helping PLM and product innovation teams really improve products and product quality. Here's another prediction for you as we look at kind of closing out some of the data today. 25% of organizations in just a couple of years, I think will be leveraging machine learning across the organization to tap into improvements around product development, supply chain, and manufacturing and service. And again, this is only a quarter of organizations, but I really see a use case for ways in which AI and machine learning can really impact the business. But it takes our entire team to think about ways in which, IT needs to, think about product innovation platforms and PLM systems and how those need to interact and engage with service businesses and breaking down silos of organizations to ensure that we're able to not just have data to support separate functions of the business, but where data is going to play a role in connecting the dots between product development, supply chain, manufacturing, and service. Can we execute on that, full view of the customer that goes all the way down to the warranty side of the business? So in order to get there, we have to educate and enable our team leads and, each group within the organization that is going to touch upon product innovation and understand that the service guys and gals do have an impact on how products are designed and how quality is being delivered. Can we get to a point where we connect that tissue to ensure that we're able to leverage that insight and intelligence and give that back to other aspects of the business? Can we look at analytics to ensure that we're able to not just, complement AI, but, connect innovation with real data and not just gut feel or the way in which the engineering team is working in a silo. And then finally, within service, can we apply machine learning technology to better plan and execute? Again, I go back to the execution piece, but I think it's integral to making that use case around machine learning and AI. Does it really help us, figure out, forecast better, what are the reserves necessary around the warranty so that we, better align with the resources available? Can we go back to customers and suppliers and let them know based off of AI, what they will need to be successful? So as you think, about your warranty processes and the service business, I want to leave you with 3 takeaways. First of all, and this should come as no shock, understand your customers. They are demanding more and shouldn't be overlooked in any decisions you make around investments and technology looking at deploying. Secondly, work on consistency of service quality. Regardless of who's interacting with the customer, whether it be the dealer, suppliers, customer support, or you as the OEM, you must all ensure everyone has the data, answers, and training to be able to deliver a consistent experience. And finally, understand that change is difficult. Invest as much in technology and tools as in the resources and training materials to ensure your team understands the reason for the change and how it will not only impact their roles, but the value being delivered. And, with that, I want to say thank you. And I'll pass it on to Atul, who will provide some insights into how Savant works with customers to support many of the trends I've discussed. Thank you.
Okay. Yeah. So thank you, Ali. Once again, my name is Atul Varshnaya. I head the artificial intelligence team at Savant. So in this section, I will talk about 2 specific use cases which illustrate the application of AI in warranty management space. Ali talked about how connected things and IoT is driving transformation in this domain, the warranty management domain, and it is transcending the hype associated with it, and also that the interest and investment in this is growing. So in line with that, I will talk about one use case in the IoT space. The other use case is more from the point of view of business processes. It deals with handling of warranty claims, identifying ones which are suspicious or fraudulent. So predictive maintenance under IoT is a fairly important use case from the perspective of warranty management. And under that, we can talk about predicting whether a certain equipment is likely to fail, how long after which it's likely to fail, which basically talks about remaining useful life. Also, it's also pretty useful in many cases to be able to determine if the performance characteristics of the equipment are not normal, or in other words, are anomalous compared to most other well-performing equipment. So while this does not indicate what the actual problem is, but it is valuable to identify some problem scenarios that are not yet caught by the AI models, basically flag such cases to be checked out by human experts, and thus provide feedback into the AI system to learn those new kinds of failure modes for future. And then the second area that I'll talk about is a suspicious warranty claim. This is the use case of identifying suspicious warranty claims using anomaly detection. All right. So before that, just a backdrop of how such solutions are implemented. Artificial intelligence is all about data. So the first step is determining feasibility of the use cases given the kind of data that we have. And that's what we call data trial. There, basically what we're trying to do is the identified use case that we're trying to address and the data that's available, we're trying to identify whether the data supports that use case. Does the data carry that kind of a signal? Does it carry that kind of an information which artificial intelligence and machine learning techniques can extract to implement the use case that we're trying? Therefore, it becomes a feasibility kind of a phase. Once established, which basically can involve either tweaking the use cases or identifying which other data elements need to be captured and stored. Once that is established, then we get onto the stage of proof of concept building. Here, the data scientist will pick the right algorithms, do the right kind of feature engineering, build models, tweak the models and iterate among them to come up with the right kind of performance measurements, and then demonstrate the results to the business. And that becomes a gate to identify whether that is a solution that has the right kind of ROI to put in production. Having done these two, then it becomes more of a software development method after that. So the solution implementation basically plans for deployment, operationalizes the model in production, and implements it and makes it work in production. But machine learning also has another nuance to it. The data and the behavior patterns keep changing. For instance, in manufacturing, you can think of the kind of parts your manufacturing processes are using can change if you're getting them from a different supplier from now on, or your manufacturing process itself can change. Then the behavior patterns that are observed in data will also change. And that requires refreshing the model periodically to update the model itself so that it remains accurate and remains up to date with the kind of reality that's there. So these are the various phases that go into implementing a machine learning solution. And this kind of gives an idea about the data versus use case aspect. So this is about some data that shows the sensor readings with respect to the failure of the equipment. So if you notice, the readings go up to here and then the yellow one fails, the readings go up to here and the green one fails, and so on. So you can see that there is some correlation between the sensor readings, the way they're changing, and the actual failure of the equipment. And this is the kind of an intuition that I wanted to bring in when I was talking about matching the data, the data that is available with the use case. Now, in reality, things are not so obvious, and there's a lot of slicing and dicing of data that's involved, but I hope it gives you a sense of what it means to look at the data and see whether it supports the use case that you're trying to meet. So what is the kind of data that is required in IoT and predictive maintenance kind of use cases? I have listed the data from left to right with respect to the frequency at which the data is collected. Static data is obviously collected only once. It talks about the configuration, capacity, model, make of the equipment. And on the complete extreme right-hand side is the fastest moving data, which is the time series data, which is collected through sensors on the device, on the equipment. Actually, these two turn out to be the most important. The time series data is the most important one. That augmented with static data about the configuration and capacity and the make and model of the equipment, these typically lead to very high level of accuracy of predictions. The other data elements which are about the usage history of the equipment, as well as about its maintenance details, also come in very handy in that order of importance. So although all are important, but the time series data, the equipment details, the usage history, and then finally the maintenance details. In that order are are the important elements to be captured for any IoT or predictive maintenance kind of use cases. Once that data is available, the data scientists extract right kind of information from those through feature extraction. These can be very simple things like count, sum, min, max, as well as they can actually be fairly complex operations like looking at frequency components through Fourier transforms or rate of change using derivatives or second derivatives of the data. So these are the kind of feature extractions that are done, and then the data is ready for being used for building the models. How do you build models is, you pick up the right kind of algorithms, and those algorithms, the algorithms that you'll pick up will depend on what exactly is the kind of use case that you're working on. Are you looking at will the equipment fail in a certain time window? That's a classification problem. Or what is the kind of failure that will happen in that time window? That is a multi-class classification, because what you're trying to do is you're trying to find out whether the diagnostic code 1 will happen or 2 will happen, or any of those will happen. So you're trying to classify among all the possible diagnostic failure codes and trying to see which of these is likely to happen in the next given time window. Then how long after which it is going to fail? That is when you're talking about give me a number of days or weeks or months after which the equipment is likely to fail. This is a regression problem where you're trying to find out a duration, a number after which the equipment is going to fail. And then the last one is, as I mentioned, another very important one, which is not trying to predict whether it's going to fail or not, or how it's going to fail, but whether it is behaving normally at all. And this comes in very handy for the kind of failure modes that are unknown to the machine learning model at a given time. So this kind of becomes like a blanket way of determining whether things are going well or not. And if they are not, then it kind of flags the equipment to be checked out by some human expert and use that as a feedback for the machine learning model to continue to learn from that point onwards. The kind of algorithms that go into building the models for all these kind of cases can be very traditional kind of methods shown at the bottom, or the more powerful techniques like the deep neural networks or deep learning, as it is commonly known as, those techniques which require more data but also provide much higher level of accuracy, or techniques which are like the recurrent neural networks, which remember the history of the equipment's behavior from the past and make predictions based on the current values observed. So if something happened to the equipment in some, even a year or two back, the recurrent neural network algorithms remember that, and as they look at the current observations coming from the sensors, they use that memory to still make predictions much more accurately about what's going to happen in future. So using these techniques, we have implemented such kind of prediction of failure codes for some industrial equipment. We were basically predicting the emission of diagnostic trouble codes 2 weeks prior to the failure of the equipment. And the data that was available for us was telematics data, static data, as well as the equipment usage data. Now, these are, as I mentioned earlier, the 3 most important data elements, and we had those available. And since we were predicting the diagnostic codes, so it became a multi-class classification problem. We used deep learning techniques, and using that, we were able to make very high level of accuracy in making those predictions that when equipment is going to fail in the next 2 weeks. The right-hand side of the slide shows you the kind of data that we were using from the sensors. Coming on to the second use case, which was about anomaly detection or about predicting fraud claim in the fraud in the claims, in the warranty claims that are received. Anomaly detection turns out to be one very effective way of doing that, because a lot of times you do not know beforehand which kind of claims should be classified as fraudulent or suspicious. Therefore, the historical data does not always capture the right kind of information about which claims should have been classified as abnormal or as fraudulent. So using that, so using anomaly detection, what we try to do is not to identify the fraudulent claims themselves, but to identify claims which do not look normal, which do not cluster along with the other kind of regular claims that have been observed. So flag the infrequently occurring anomalous conditions for action, and the action is to be given to human experts so that they can look at it and then tell whether this does look like a fraudulent claim or not. So that is the technique that we use for doing for identifying warranty claims that are suspicious or fraudulent. So we take all the data that's available about the claim and pass it through an anomaly detection mechanism and flag the ones that do look not normal or look out of ordinary, and flag those to the human experts. Once we have the information about which are the ones which were actually fraudulent, which is pretty high likelihood of, because of the anomaly detection to be fraudulent, we use that as a feedback into the learning of the machine learning algorithms to start identifying those as fraudulent claims in future. While we continue to learn, it is important to still continue to identify anomalous claims, because the way the people commit fraud keeps changing. Therefore, whatever we have learned through our historical data, that helps us identify those kind of fraudulent claims. But as people evolve their way of committing frauds, anomaly detection is the umbrella that helps to identify those kind of fraudulent claims too. So this is the way in which we have implemented a machine learning solution for identifying fraud in warranty claims. And that kind of concludes my section with respect to the two use cases that I was hoping to cover.
All right, thank you, Atul. We will now open the session for questions. And it looks like we have a couple of questions already. The first question is for Ali, and it is, our company still manages warranties as a cost center. How do I get a buy-in to transform to a profit-centric model?
Yeah, that's a really good question. I hear that quite a bit across a number of industries, obviously not service only companies, but like manufacturers and utilities companies who struggle with the service side of the business being viewed as a cost center or a pathway to contain more costs around efficiency. And I would say that the first way to kind of evolve is one is bottom down and the other is top down. So from bottom down perspective, I think it's important for you to gain access and feedback from customers, so get their sentiment around specific processes associated with service. So if you can directly connect the customer experience and the value they're receiving from the service set of processes, whether it be warranty or, to Atul's point, maintenance and service execution, and connect that to dollars lost or dollars won based off of improving their experience and improving the way in which you're delivering services. I think that's one way to move the needle around and becoming more a view that service is a differentiator for your business and not just something to cut costs because you sold a piece of equipment or you installed a product. I think the other one's from top down. I mean, it's kind of hard to say, but as leaders of the service business, it's important for you to go back to your boards and your IT teams and your CEOs and let them know, the service side of the organization is the face of many of your businesses. And it's important for that to be the driver of what moves sales and moves marketing, moves your organization forward, and actually advocating for services. And I know you're all doing that. Most of the attendees on this call I talk with at conferences and on webinars. I know we're all beating the drum around service, but I think that's the best way to think about ways in which you can move from a cost-centric view of service to more of a profit-centric view.
Thank you, Ali. Okay, so from the sound of it, it looks like our next question is for Atul. And the question is, why is there so much hype on deep learning? In what cases is it of any real value?
Yeah, that's a pretty pertinent question. The machine learning techniques, the traditional techniques like logistic regression, random forest and others have served us well for quite a few years, but as it happens, deep learning or deep neural networks is actually becoming is being seen as among the most powerful techniques in machine learning. And the core reason for that is that it deals with all kinds of non-linear. So it's actually called as the most general way of modeling any kind of patterns in the data. And that basically brings the biggest power to deep neural networks. Now, the flip side of that is that deep neural networks do require a lot of data to deliver their promise of high accuracy of predictions. And considering the amount of data that's available nowadays in various businesses or various industries, various verticals, that problem is almost gone away or is in the process of going away. And therefore, the applicability of deep neural networks is becoming more and more real, and the promise of them being able to provide very high level of accuracy in making predictions, it can be realized. So that would be, in fact, in our work, deep neural networks is my go-to algorithm before we try anything else, because of the power that it brings for building solutions.
Thank you, Atul. All right, the next question is for Ali, and here it goes. Warranty management historically has prioritized cost containment. Why is this still the norm for many organizations?
Yeah, I think that question goes back to the first one that was posed. And I think the biggest deterrent to moving warranty beyond just cost containment is thinking about service and the service side of the business as being the main or the potential to be the best differentiator for your business and for your brand. And that goes all the way down to warranty. I think organizations that I've seen move down the maturity curve around, where service plays a role, probably start with field service and maintenance and, ways in which you can sell better parts and consumables, and then warranties after that, right? I advocate, and I'm pretty passionate about, pretty passionate about the warranty side of the business and covering the space. I think this should be one of the main drivers of differentiating for your organization. It shouldn't just be a cost containment. I think the next level below that, and why it has kind of stayed in this cost priority for organizations, has been legacy systems. It's been complex dealer networks that are still on old, green screens. It's been around how innovations have started with the PLM product side or with an ERP, and then moved maybe to field service and mobility, and then IoT and AI, and haven't quite gotten to warranty. So as we start building that use case around the way in which warranty management impacts the customer relationship, I think we'll get to that next level where we no longer say equate warranty with cost, and actually equate warranty with differentiation, value, the consumer experience, the dealer engagement model, and actually get past that next level.
Thank you, Ali. We do have a couple of more questions, but in the interest of time, we will conclude the session today. Thank you, Ali. Thank you, Atul. You were great. Thank you, everyone. We appreciate you being here. In case your question was not answered today, please expect a response from us in the next 24 hours. Have a great day.